Okay, this is chapter 1-4. This is recording number 1. Okay, let's take a quick look at the outline again. We've talked about the different types of statistics. We've talked about the different types of data and variables. We've talked about data collection. How do we gather the data? What are the different techniques that we can use for sampling? And as I've mentioned before, if you don't sample properly, your results are going to be very misleading and incorrect. We're we're not going to talk too much about that anymore. As far as I can recall, we don't discuss the sampling techniques anymore, but it's something that you should be aware of. Next thing is going to be experimental design. How do we design our experiments? There's two basic types of studies. There's different types, of course, there's several different types, but the two basic types that we're going to look at are called observational studies and experimental studies. Okay. So again, keep in mind what's a good example for you. What is of interest to you? If you're a business major, it's going to be different than if you're a nursing student major. So keep in mind what is a good example for you, and that way you can relate all of this stuff to your example. It will make a lot more sense. I promise you that. So we got the two different types, observational and experimental. Observational, as the name implies, you're merely observing, you're watching. You're not doing anything to interfere, you're not changing anything, you're not doing anything at all, okay? So observational study, you just observe. So here's an example, okay? You just observe what's going on. Now, if you're just observing, there's different ways that you can observe. So that's why it's further categorized or divided into three main types of observational studies. If you collect all the data at one time, it's called a cross-sectional study. I'm not sure why they call it that, okay? If you get records from the past, it's retrospective. Now that makes sense. And you look at something in retrospect, you're looking backwards in time, right? If you're looking at it over a period of time, then we call that a longitudinal study. So for example, you go to, let's take nurses as an example. Okay, you start with kindergarten kids, you go in there, you do something or another, you observe them, and then every year you measure something year after year after year after year. So that's kind of a medical study that you might do. And since you're doing it year after year after year, we call that a longitudinal study. Going back to the cross-sectional, I guess the distinction there is that if information is collected all at once, we call that cross-sectional. Okay, there's advantages and disadvantages to it. I mean, you can't say one is better than the other. It depends upon what your goal is, of course. Okay, all right. One advantage is that of an observational is it's in some sort of a natural setting. You just go and you observe people doing something or another. Okay, so I'll let you read that. There's also disadvantages. Okay, all right. It can be very time consuming, very, very expensive. Okay. So I'll let you read all that yourself. The experimental study is the one that we're kind of all a little more used to thinking about, maybe reading about in the newspaper. Experimental study, the researcher manipulates, they do something, they manipulate one of the variables, and you try to determine how the manipulation influences other variables. So the example I think about all the time is you give people a vaccine. So you have a control group, no vaccine. The experimental group or the research group is also often called it's also called the experimental group. You give them the vaccine. The group that you give nothing to, we call that the control group. So then you compare the two control group. You compare the control group to the experimental group. That way you can try to decide, is there a difference between people that receive the vaccine versus people that do not receive the vaccine? So you're playing around with something, you're manipulating something. So that's what an experimental study is all about. Okay. Here's an example. I'll let you read that. Okay. It talks about how the subject should be assigned to groups randomly. Okay. All right. So another thing that we want to discuss is if a random assignment is not possible, researchers use intact groups. So that's where you already have an intact group. That would be like an example. You're trying to experiment with kids. If they eat their Wheaties, do they do better at doing their push-ups. Well, you already have kids in a classroom, so you just go to each classroom, and this classroom, they eat their Wheaties. The other classroom, they don't eat their Wheaties. So they're already an intact group, okay? So that's a kind of a nuance I'm not sure we're really particularly concerned with, okay? Okay, so what we normally will see is an independent variable and a dependent variable, okay? That's what we normally will see. Now, let's make sure we understand the difference. An independent variable is the one that's being manipulated, okay? So you can manipulate the independent variable. It's also called the explanatory variable. The reason we call it an explanatory variable is because it explains things. Explanatory means explain, right? So if you are explaining something, we call it an explanatory variable. Now, why is that the independent variable? It's the independent variable because you can manipulate that. You can change that. You can give people the vaccine. You can make them eat Wheaties. You can do whatever. Whatever you're manipulating, that's the independent variable. The resultant variable, the variable that results, the one that results from this experiment, we call that the dependent variable. It's depending upon the first variable. It's also called the outcome variable. So does that all make sense to you? Hopefully it does. Read it over again if it doesn't, okay? I'm not crazy about their examples. I'm just kind of stuck with them though, okay? The dependent in the sit-up study, the dependent variable was how many the number of sit-ups that they could do. That was the dependent variable. The independent variable was what you said to them. Okay, that was up here in the example. Maybe I should have read that to you. The first group was told do your best. The second group was told increase it each day by 10%. Okay, so who does better? All right, so that's the variable that is dependent. That's the one, or independent, excuse me. The independent variable is what are they told? Two different things they're told. Okay. All right, so we have a treatment group. That's the group that receives the special instruction, or that's the group that receives the vaccine. That's the ones that something is done to them. Whereas the control group it does not receive the vaccine, does not eat the Wheaties, does not get the particular instructions, okay? So there's advantages and disadvantages of both. I'll let you read that yourself, okay? This is a very common effect, well-known effect called the Hawthorne effect. When people are part of a study, if they know they're part of a study, it can modify their behavior. And that's just human nature. That's just the way human beings are. They act differently if they know they're being observed, okay? This right here, I wish they'd spend a little more time on this confounding variable, also known as a lurking variable. And what that is referring to is that so many times, especially in social sciences, is they think that they are testing for something or another, but they really are not, okay? And you just don't know. They're confounding variables. They confound you. They confuse you, all right? Or they're lurking. They're things that you don't know about, okay? Try to come up with a really good example that's not too controversial. I can't be controversial. I get in trouble. So let's take current events here, the pandemic situation going on right now. I'm going to totally make this stuff up, okay? This is not actual data. This is just, I'm making this up to illustrate the point I'm trying to make. Let's suppose for the sake of this discussion, okay, that you were looking at the COVID death rates, okay, and you said, okay, the death rates for, I'm making this up, the death rates for Hispanics is 2%. Okay, 2% of the people that get sick die if they're Hispanic, whereas only 1% of Caucasians die. Okay, so you would look at that and you'd say, oh my gosh, there's a big difference here. It's 2% compared to 1%. That sounds ominous. That sounds like what's going on here. That sounds important, right? The confounding variable, the lurking variable might be, what kind of a job do these people have? If you're looking at Hispanics, they might be disproportionately in a job that requires personal contact, a job that is very difficult to maintain social distancing. Therefore, the it's not the race, it's the job. Maybe if you looked at it and you divided things up and you said, okay, if you have a job that requires personal contact as opposed to a job that does not require personal contact, what's the death rate? And it might very well be, and I'm totally making this up, it might be that if you have a job that requires personal contact, it's a 2% death rate. And if you have a job that does not require personal contact, it's a 1% death rate. So do you see what's going on here? Is that you think you're looking at this variable of race, but that's the wrong variable. It has nothing to do with race. It has to do with what kind of a job you have. So those are confounding variables, otherwise known as lurking variables. It's the hardest thing in the world to figure out if you're testing for the right thing. And that's why guys and women, men and women both, will write their PhD dissertation on this issue of how do you decide whether you have confounding variables or not. Okay. This is talking about the placebo effect. A placebo effect is where a placebo is something that should have no effect. Let's say you're testing an oral vaccine. So half the people get the real vaccine, and half the people get a Tic Tac candy, a sugar pill. Okay. It turns out that Tic Tac sugar pill will have good effects. It will have it will ameliorate, or it will mitigate whatever it is that you're trying to reduce. Okay, so it just turns out that that's the way it is. Human beings that's just the way they are. If they get a pill, they think it's going to do some good. It will do some good. Okay, so this is what he's talking about here. They respond favorably, or they show improvement just because they've been selected for the study, just because they've been given the sugar pill. So when it comes to medical research, it's a very, very important issue, because the Federal Drug Administration, the Food and Drug Administration, they have to decide, first of all, is the new medication, is it safe? And then they have to decide, is it effective? Well, deciding if it's safe or not, that's pretty easy. But deciding whether it's effective is not easy because of this placebo effect. Okay, so this blinding is where nobody knows what if you're getting the sugar pill or if you're getting the vaccine or not. And sometimes they'll do it double blinding, where even the researchers don't know, and that way it prevents people from getting clues. Okay. All right. There's a matched pair design. They're paired, like husband and wife would be an example, brothers and sisters, things like that. They'll match them up. Okay, and then one of them goes to the treatment group, the other one goes to a control group. Classic example of that might be twins. You get twins, and one of them gets the vaccine, and one of them doesn't get the vaccine. Is there a difference between them? Because DNA-wise, you think they're just about the same, right? Or are the same. So that would be an example of a matched pair design. And then replication is where that's kind of the essence of scientific studies. Is somebody reports a finding, they publish it in a journal, and then somebody at another facility, another university, they try to replicate it. Okay, that's called replication. Okay, so I'm gonna let you guys read this. I think it's pretty straightforward. I think you can read this yourself. Okay, I'm gonna get into more detail when we get into the later chapters, starting with chapter 4. Oh, here's about statistics and the uses and misuses of statistics. I'll let you read that yourself. I'm sure you've heard that many, many times. They'll say, well, you can prove anything with statistics. That's absolutely not true. You can misuse statistics. You can, you misuse just about anything, right? But statistics itself is very valid, very good science. It's used all the time to make very, very important decisions. But if you don't know what you're doing, obviously, you can make mistakes. So all of this is very straightforward. It's not really math. It's more of just a common sense type stuff. Okay, so that's the end of this video. This is a video for chapter 1-4. This is recording number 1.